Hi everyone. In today's lesson, we will take our first step in developing a Java multi-project. The video will be divided into questions and hands-on solutions. So, what do we need? Java JDK, Gradle build tool, and for IDE, we will use the VS Code with Java support. For those who are new to this channel, we can use my previous videos to learn how to install and configure VS Code and set up Java environment. You also have an elaborate video describing the creation of a basic Java multi-project in Gradle. A multi-project build in Gradle consists of one root project and at least one or more sub-projects. To align with the Java terminology, let's call root project a solution and sub-project as a project. In Java language, the code is divided into logical layers, which are package and model. But if you have a large project that you want to split to easily manage it, you can use the solution as it provides another logical layer. To clarify, the solution itself does not produce jar file, but it serves as a container to other projects by consolidating them under one build flow. In Java, every project produces a jar file which is used as part of the development. Using Gradle solution can bind together projects to provide the end goal. Gradle also lets you build every one of the projects separately. Let's open the terminal, and we want to use the CMD terminal instead of the default, which is PowerShell. To do so, we'll select Terminal, New Terminal in the menu, and you can see the default terminal is PowerShell. So let's turn it into CMD. We'll check the plus drop-down, then select the default profile, which is command prompt. Let's close the terminal and create a new one. And now you can see that the terminal is CMD. Let's start by creating the basic solution. We'll start by opening the terminal in the VS Code IDE, and then we'll create the solution directory. We'll call it for now com-fastestqa. Then navigate into the directory and run the command Gradle init. We'll select the library project type, implement in Java language, use the Kotlin build script language, and JUnit as the testing framework. The project name will be the default, and for package name, we'll use com.fastestqa.core because we want the first project to be the core project for the entire infrastructure. The default Java will be 21 as installed previously, and we will use the new build API. So for that question, we'll say yes. And that's it. The build is successful. And now let's open the solution. So after opening the solution, you can see a couple of directories and files. The first one is .gradle, which is a directory for Gradle to use as a cache directory so it can run faster. The Gradle directory contains the jar file and configuration for the Gradle wrapper, which means you can use Gradle as a standalone in your solution. You don't need to install Gradle on your machine. So it's a standalone Gradle. Gradle properties is a key value file that contains properties for the solution. You can add values so the solution can pass it through the project in this solution and use it as environment variables. The Gradle W and the Gradle W.bat are scripts. The bat is for Windows and the Gradle W is for Unix, Mac OS. Those are scripts that can execute builds using the Gradle wrapper. You can use them to run Gradle, the Gradle wrapper on your solution. The settings Gradle file is the solution settings file where the list of projects are defined. So if you need to add new project, you have to list it in this file for the solution to recognize it and build it. As part of the solution, Gradle also created us a new project which is called lib, where you write your code. For the first act, we will rename the project lib to core, as we did it in the package name. To do so, we'll select the directory and rename it. We will open the settings Gradle file, and you can see that the include method is calling the lib project instead of the new name. Let's rename it and also save. Let's try to compile it. So imagine that you have a solution with multiple projects, and every project has its own tasks. But you see that there are some tasks that are duplicate for every project. So for the sake of good writing, what if we had one project that encapsulates all the duplicate code of the build process into one project that every other project can use? That idea is applicable in Gradle with a feature that is called composite build. The main purpose of the composite build, or some call it build source, is to write tasks, plugins, and classes to be used in the solutions project. So how do we do it? Let's start by creating the directory for the build source project. We will name it build logic. Next, we'll create the folder structure for this project. So we'll add source main Java like a regular Java project. And let's give the package the name com_fastSQA build. It will serve us as the Java source code when creating classes. Next, creating a Kotlin directory where all the Kotlin scripts will be. You can see the new project in the Explorer view of the VS Code. To clarify, the new project is not a development project. Rather, it is a build project that Gradle can use as a plugin to build development projects in this solution. As to every project, we will add the build Gradle script. Let's add the Kotlin DSL plugin so it will support Kotlin language, and to the repositories, a section that will tell the project from where it can download plugins, which is the Gradle plugin portal. Now let's add build script to be used in the other projects. We'll add the new Kotlin script and rename it com fastSQA library convention.gradle. The name suggests that we'll use it in the projects that are Java library type. We'll open the core project in the build Gradle script and copy the sections to the new library convention script. Let's go back to the build script of the core project. Delete the code and instead we'll add a call to the plugins method. Add a closure and in it a call to the library conventions build script using the IDE method. You should omit the .gradle.kts suffix when passing the string. To notify Gradle about the build source project, open the solution settings Gradle file. Let's clear the plugin closure and add a plugin management closure. In it, add a call to include build and pass a string parameter with the name of the project we created. So to review, we created a build project and name it build logic. Inside of it, we've created a build script. Copy the content from the core project to the new build script. Then, in the build script of the core project, we've replaced the content with a call to the build script inside the build logic project. To notify Gradle about the build project, in the settings Gradle script, we passed the name of the project to the include build method. To test the changes, let's rebuild the solution. In the terminal, run the Gradle clean build command. To review the output, we can redirect the standard output and errors to a file. Let's call it build.log. As you can see, Gradle identified the build logic as a build project and build it first. Then Gradle uses the build script from the build logic to build the core project. And to view it in more details, you can add the info switch. Thank you for viewing my video, and I hope you find it helpful. If you do, please like and subscribe to my channel. Goodbye and have a productive day.